Hello students, today we will be discussing about the general physiology. In general physiology, this is the topic list. First we will be discussing about the homeostasis. It is not hemostasis, it is homeostasis and the control system. Next, blood fluid distribution and measurement. Next comes the Darrow-Yannet diagram. Then transport across cell membrane and finally the cell structure and some of the other cell connections also we will study. In this, we might think that it is a general physiology, but still repeatedly MCQs has been asked, especially in this control system. Last few years back also it is asked, and this body fluid and measurement, everything is important. So all the general physiology topics, it's easy to understand and it's important also. So let's get into the topic. First, coming to homeostasis and control system. What is homeostasis? All of us know it is the maintenance of normal internal environment. This normal internal environment maintenance was initially referred as the maintenance of ECF. ECF was considered as an internal environment and maintenance of it is called as the homeostasis. It was termed as milli-interior by the scientist, that is Claude Bernard. So this scientist Claude Bernard has initially termed as it is as milli-interior. Now coming to the control system. There are few control systems which are regulating to maintain this homeostasis. They are doing it via the feedback mechanisms. One is called as the feedback mechanisms and another one is feed forward mechanism. First, we'll discuss the feed forward. Feed forward, as the name indicates, it is going in forward. Before the event is happening, some corrections are happening. That is feed forward mechanism. It is happening in anticipating mechanisms. So this is anticipating the event, and before the event happens, some correction is happening. That's why it is called as feed forward mechanism. Let's see some examples for better understanding. Suppose you are waiting for a running track and you are on the track. Even before you start to run, what will happen? There will be an increase in BP as well as an increase in heart rate. Both of this is happening before you start running. That's why this is called as feed forward. Before the event is happening, there is some change in the body. And next example is cephalic phase of gastric secretion. Even when we look at the food, our gastric acid is being secreted, or hear the sounds of or smell of the food, then again gastric acid secreted. So this is happening. The food has not reached the stomach, but some mechanisms are activated before that. That's why it is called feed forward mechanism. Then there is receptive relaxation of the stomach. Whenever we put something in the mouth, like food or any snack in the mouth, what will happen? The stomach is already starting to relax. That is called as the receptive relaxation of the stomach. This is also happening, anticipating that the food will come to the stomach. And one more feed forward inhibition is there, which we will study in the CNS, which is happening in the cerebellar circuit. Cerebellum circuit had feed forward inhibition. Feed forward inhibition. So coming to the feedback mechanisms. The feedback mechanisms are positive feedback mechanism is there and negative feedback mechanism is there. Most of the feedback mechanisms in our body are negative. So we are not going to study the examples of it. Whatever is studied in the positive feedback, rest everything is in the negative feedback mechanism. So coming to the positive feedback mechanism, what is feedback? Feedback means it has to come back and to the same original first starting point. For example, A is stimulating B and B is stimulating C. Then finally this product C will go and stimulate A. So this is the positive. Everywhere positive feedback is happening. So everywhere the connection is going in a positive direction. So the examples for it is very, very important, because the questions usually asked are all of the following are examples of positive feedback except, or all of the following are examples of negative feedback except. So this is the common question asked. So we have to mug up all the examples of it. So first comes activation of sodium channels in case of action potential. Whenever action potential is happening, what happens? There is input of sodium ions. Whenever few sodium channels are open, they positively open up all the sodium channels that is required. So this is an example of positive feedback mechanism. Then blood clotting. Whenever platelet factors or the clotting factors start to accumulate in an area and form the thrombus, they ultimately keep on forming the thrombus until the fibrinolytic system is activated. So this mechanism acts in a positive way. So this is thrombus formation. Thrombus formation is an example of positive feedback mechanism. Then coming to three things which are in the females which is happening, that is the lactation. Lactation, what happens is whenever there is suckling of the baby, what will happen is oxytocin is produced, and this oxytocin will increase the milk production. And this cycle keeps on happening. Milk let down reflex it is called. It is It is also called milk let down reflex. This lactation is also an example of positive feedback. Then contraction of uterus. Obviously, we want a positive feedback because whenever the baby is about to be delivered, parturition is happening. The oxytocin, what it does is it starts contracting. If it is a negative feedback, what will happen? It will stop the contraction, which we don't want. We want more and more contraction to happen so that the baby can be expelled out. So this contraction is uterus by oxytocin is also a positive feedback. Then the LH surge before ovulation is also a mechanism for positive feedback. Usually the estrogen inhibits the LH, but this is one place where there is an LH which is increasing its own production and the estrogen is also increasing its production. So this LH surge before ovulation is also a positive feedback mechanism. So we can club this three, that is lactation, parturition and ovulation. So all these three events we can club it together to remember. Then CCK release. What is CCK? It is nothing but the cholecystokinin. Cholecystokinin release. This cholecystokinin release is also an example of positive feedback. And coming to the one positive feedback which is not so positive, it is negative or detrimental to the body. What happens in shock is there is depletion of tissue supply of blood. So tissue is getting less blood. So what will happen? Tissue injury will happen and even the cardiac tissue is affected. And cardiac tissue is affected, so there will be a further decrease in the supply. So this is happening as a vicious cycle. This is also called as vicious cycle and it is very detrimental to the person. Now coming to the negative feedback, rest apart from these examples, rest everything that is happening in the body is a negative feedback mechanism. So one of the classical example that is studied is BP regulation by the baroreceptors. So what the baroreceptor does, whenever there is a rise in BP, it will be sensed and it decreases the BP. At the same time, whenever there is a fall in BP, it will try to increase the BP. It is happening in a reverse direction. So here the event is happening in a reverse direction. In a similar example, A is stimulating B, then B is stimulating C. This ultimately should inhibit this first part, that is the negative feedback mechanism. And effectiveness of any negative feedback mechanism is given with the help of a formula that is called as gain. Gain is nothing but correction upon error. For example, let's take the BP measurement. Suppose somebody BP shoots from 120 to 180, maybe they are exercising. What the baroreceptor will do is after some time they'll try to bring it back to normal. It brings it back to around say 140. Usually it does not bring it back to the exact same value immediately. So the gain here is correction by error. How much it has corrected? 40. From 180 to 140 it has corrected. So the correction is 40. And what is the limiting factor? Like how much is left over? That is the error. Minus 20 is the error. So the gain will become negative 2, minus 2. If a system is having zero error, what will happen? The denominator will become 0 and the gain will be of infinity. Is there any system like that? It is like a perfect system for the body. So the regulation of BP by the kidneys, that is the renal regulation of the BP, will always try to bring back the BP to the exact normal value. So here the error happens is 0. So the gain becomes infinity. So this is one important factor where the gain is infinity, which can be asked as a question.